So, now we will be doing here different types of vectors. So, here we can write here types of vectors. First we can take here equal vectors. See here in equal vectors, two vectors have got like this is here, suppose same direction and same magnitude like vector A and vector B. These two are having the same direction and same magnitude, they are called equal vectors. They can be written also like this, here and here, this is A and B. They also can be written as equal vectors. So, the magnitude is same and direction is same. Now, we can write here negative vectors. Negative vectors having the equal magnitude, but opposite direction, like 1, if you have taken vector A, so vector B will be to this side, this is called here negative vectors or opposite vectors. Like 1 you can take here A here and B you can take here like this, they are also negative vectors. So, these two are equal vector and negative vectors. Also we can take other type of vectors, like we can take a 0 vector. See a 0 vector, it has got magnitude 0, but direction is arbitrary, that is or unspecified. So, any vector whose magnitude is 0 and direction is arbitrary, that is not specified, is known as 0 vector. 0 vector is represented by this. But now another question is here, why do we need? Like a body is at rest, you have its velocity 0. Body is moving with the uniform velocity, you have to say body has acceleration 0. So, this acceleration is 0 vector and body is at rest, velocity is a 0 vector. So, these are example of the 0 vectors. Now, see here some properties. Suppose if you have got a vector A and you add a 0 vector. So, when a vector is added by a null vector, this 0 vector also we can call it null vector. So, when you add a 0 vector here, you will not be getting any change in the answer, that will remain the vector A. Similarly, if you have got vector A and minus null vector is also remains vector A. Now, if you have taken like a vector A and multiplied by a 0 here, that will become here now 0 vector. If you have taken any vector like this thing is here, any number n into multiplied by 0 vector is equal to here 0 vector. So, these are the certain properties of the 0 vector. Now, after 0 vector we will come back to the, we will go for the next vector, that is called unit vector. What is unit vector? Say a unit vector has got magnitude unity, and direction, and it has direction along the given vector. So, how do we represent unit vector? Suppose you have got vector A like this is here and you want to write its unit vector. How we will write here? We can take unit vector of this, unit vector of vector A is vector A divided by magnitude of vector A, and this is equal to A, and we write here a symbol cap. So, when we write A cap, that means a unit vector. So, unit vector of a given vector A is equal to vector divided by its magnitude. It is equal to A cap means that is unit vector. Now, we use actually 3 unit vectors here. If you take like the x, y and z axis, you have got 3 axes x, y and z. All these 3 axes, this is the point O origin. Along x axis, positive x axis, we take always unit vector I cap. Along the positive y axis, we take unit vector j cap, and along positive z axis, we take unit vector k cap. So, basically we use here 3 unit vectors I cap, j cap and k cap. As I have told you, along positive x axis I cap, so along negative x axis it will be minus I cap. Along positive y axis j cap, so along negative y axis it will be here minus j cap, and along positive z axis k cap, so along negative z axis is minus k cap. So, these things are about unit vector. Now, we will take another one like a co-initial vector. Co-initial vectors, suppose you have got the two vectors like this point is here vector A and vector B, vector C. All these three vectors have the same starting point. These vectors are known as co-initial vectors. Similarly, we can write coplanar vector. In coplanar vectors, there are the suppose two vectors vector A and vector B. Vectors are lying in the same plane, then we say these vectors are coplanar vectors. So, now these are the different types of vectors. Now, we will see the another type of the vectors like a position vector, displacement vector, and how do we find displacement, everything now we will be doing in the next slide. So, now we will see another type of vector that is called position vector. Now, see in position vector, suppose you have taken xy plane, this is x axis and this is y axis. Any point or any object is lying at this point, this we can refer as P and this is origin. So, from here we can write a position like this. From origin its position is here this, we can write r vector. So, r can be referred here as a position vector. This P has got a coordinate x and y. So, obviously along x axis this is here x and this one is known as here y. In vector form we can write r vector is equal to, r is a position vector, we can write here is equal to x I cap plus y j cap. X I, it is a vector along x axis, it is a vector along y axis. This has become vector by multiplying this unit vector j cap and this is r. So, here r is known as position vector. See here in displacement vector, again if we have suppose chosen xy plane, this is the origin here. Initially suppose point is over here, that point is taken as A and its position vector from origin is r1. After some time it goes to the here point B and its position vector from this point is r2. So, OA is initial position, OB is final position and AB is here the vector that is called a displacement vector. So, we can write here actually OB is equal to OA plus AB. AB is taken here as a displacement vector. So, we can write here AB is equal to OB minus OA and that we can write R2 minus R1. Also, we can write AB is equal to, we can put the value of R2. So, that will be here x2 I cap plus y2 j cap minus x1 I cap plus y1 j cap. So, this is known as here the displacement vector. We can write also delta r. x2 we can write here x2 minus x1 I cap and then we can write here plus y2 minus y1 j cap. This is known as this. But if you want to find out its magnitude, what will be its magnitude? We can take modulus of this, r is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square. So, this we can take as a magnitude. So, this is about displacement vector. Now, we can do multiplication of a vector by a scalar quantity. So, multiplication of a vector by a real number. Suppose you have got any vector A and if it is multiplied by n. So, when it is multiplied by n, n is a real number. So, now it will become here n a cap vector. So, and if it is taken here the negative numbers, a negative real number, so that will be here minus 2 or the minus n. So, this sign of the vector depend on the direction of the vector depends on the sign of the number. Suppose you have got a vector A like this and it is multiplied by 2. So, this will be here twice of A. If you are multiplying by minus 2, it will become like this minus 2A. So, when you multiply any vector by a real number, its magnitude increases according to the number multiplied, but and if it is a negative, so direction also gets reversed, gets changed, and if it is positive, then direction does not get changed. So, after multiplication of number, multiplication of a vector, we have to come to the next topic, that is actually addition and subtraction of vector. So, now we have to do resultant vectors. See here, what do you mean by resultant vector? Resultant vector means is here, that is if suppose if you have got many vectors, they are acting at different angles and their combined effect represented by one vector which has got the same nature as the individual vector has. Then that vector which is acting as a combined effect of all individual vectors together is known as resultant vector. Suppose you have taken one force is acting to this side, another force is acting to this side, their resultant is represented by like this, that is F. So, there are the two vectors F1 in this side, F2 this side. The combined effect of these two vectors is this one and this one is known as resultant vector. But see here, the nature of all these vectors are same. It means the nature of the resultant vector is same as these two vectors. Now, in the resultant vectors, it is a in many cases it is very important, like even this is about the force. Similarly, with the velocities, two velocities in the two different directions, and then you can get the resultant. Similarly, with the acceleration. Now, I am coming to the next topic, that is called vector addition. See here, vector addition, it can be done by the two ways, geometrically or graphically. So, there are laws to add two vector quantities or the more vector quantities. First, I will take here the triangle law of vector addition. Triangle law of vector addition. Now, see here in this case, if you have got two vectors like vector A over here represented by this is O and P, another vector you have taken like this vector B, this is represented by Q. So, these two vector A and B are representing fully two sides of the triangle taken in the same order. Then the third side, which is closing the triangle, taken in opposite order, is known as the resultant of these two vectors. So, this is R and this R is equal to vector A plus vector B. So, we can add two vectors by triangle law of vector addition. So, this I have taken geometrically. Now, graphically also you can take, suppose you have got one vector like this is here A and another vector you have taken like this is a vector B. If you want to add these two vectors, what will you do? Take the vector A, shift another vector to this point is here, that is vector b. Then the third side which is closing here, that is known as again here r is equal to vector a plus vector b. So, this is about triangle law of vector addition, but I am not getting the magnitude of this vector, just I have taken the vector values vector r. Now, we can take parallelogram law of vector addition. So, in this here parallelogram law of vector addition. In this case, suppose you have taken two vectors like vector A and vector B. These two are representing two adjacent sides of a parallelogram. So, now drawing a parallel vector to this side here, this is B, parallel to this over here, this is vector A, and now you have got this OPQ and here we can take S. So, now the diagonal of this parallelogram is representing resultant vector of these two vectors. So, we can write r is equal to vector A plus vector B. So, according to parallelogram law of vector addition, we take the two vectors which are representing two adjacent sides of a parallelogram. Then we construct a parallelogram here, and the diagonal of the parallelogram is representing resultant of these two vectors A and B. But also this is not the magnitude, we will be calculating magnitude later on.